Okay, this class we will introduce the default OSPF route distribution lab. So first is the introduction, and for the background, we have to know it. To enable easy internet access for employees, a company established a network with one router, one core switch, and multiple access switches. So the OSPF protocol was implemented throughout the network to streamline management and issue device connectivity. So the network administrator intends to complete OSPF configurations as needed. Okay, so this is our default OSPF router distribution topology, and we can see we have one PC and two PC as the client, and another PC as the server. Okay, and we will enable the OSPF, and then that's the SW1 and R2 belongs to the OSPF area 0. Okay, and for this topology, actually, on SW1, we create two broadcast domain. One is the VLAN 10, and second is the VLAN 20. For the VLAN 10, and the segment is 192.168.10, and the net mask is 24. For VLAN 20, the net mask is 24, and the segment is 192.168.20. Okay, so this is the IP address configuration. And after this, we will see between the SW1 and R2, the IP address is 12.0.0. and segment is 24. And between the R1 and R2, the net mask is 24, and the segment is 100.1.1.0. For this part is the internet part, okay? And between the R1 and server, we use the 202.16.1, and segment is 24, okay? So for this lab, we have two purposes. First is to master two methods for distributing different OSPF routes. First, actually, is distributes default OSPF is the default original information. Okay, and the second we will add the always. So to master the commands for distributing default OSPF routes and find the differences between two methods. So here we will see the requirements, and the first requirement is SW1 is a line core switch. So here SW1 is our core switch with two segments, is the VLAN 10 and the VLAN 20. So the IP address configuration we have introduced, right? And their gateways are 192.168.10.254. And another gateway is 192.168.20.254. So here we can see the PC's gateway is the interface of SW1. And for the PC2's gateways, of course, is the interface of SW1. Okay, so we will configure the IP address on PC1 and then configure the net mask and the gateway information, right? Okay, the second is the interconnection addresses of SW1 and R2 device, and the R2 device and R1 device. So this IP address, actually, we have introduced it. So after this, we will configure the R1 service as the server gateway with a gateway address of 202.16.1.254, and the server's IP address is 202.16.1.1. So here we can see on the topology, the server will configure the IP address, net mask, and the gateway information. Okay, so the R1 actually is a gateway for the server. And next, the requirement is the OSPF protocol is configured between R2 and SW1, and the default route is distributed on R2 to allow line users to access the internet server. So here we can see we will enable OSPF process on SW1 and R2, but for the interface gigabit 0, we don't add this interface into the area 0 because this interface belongs to the internet. Okay, so be carefully. And the last requirement is the line user. PC1 can access the server resources of the internet, but line user PC2 cannot. So here we can see the topology, right? And for the user resources, and PC1 can access, but PC2 can't access. So actually here, we will create the ACL, right, and capture the PC1's traffic and permit the PC1 to access, but we delete the PC2's traffic. Okay. So next is our configuration plane. And first we have to configure basic configuration, like the IP address, create the loopback IP address, right? And after this, we will do the R2 distribute a default router for the OSPF process. So before distribute a default route, we will enable OSPF process and set the OSPF route ID. Okay, and after this, we will network the segment to OSPF process. Okay, and then after the R2 distribute a default router for the OSPF process to meet the requirement 6. Actually, we have to create the ACL, okay, and to let the PC1's traffic go through, but delay the PC2's traffic. Okay, now we will go to see the procedure. So first we have to complete the basic configuration. Here is the PC1 and PC2 and server. So 3 PCs we have to configure the IP address and the net mask and the gateway information. Okay, so after this we will create the WLAN information and add the interface to WLAN. After this, we will configure the SVI interface for the IP address. Okay. So next, we will use our lab environment to do this lab and show how to do this lab. Okay. So actually, we have prepared the topology, right? And here you can see. And for this topology, we can see first, we have to configure the PC1 and PC2's IP. So first, from the one device is PC1, okay. And the IP address is 192.168.10.1, okay. And the net mask is 24. So the gateway information is 192.168.10.254. Okay, this is the PC1 IP address and gateway information. So after this, we will configure the PC2. Okay. And after we configure this IP address, the PC will check for duplicated address so that to avoid the IP address conflict. Okay. So next is the PC2, right? And we open the PC2. Okay. The IP address actually is 192.168.21. The gateway information is 192.168.20.254. Okay, now we finished the PC2, and the next is for the server, right? And the server IP is 202.16.1.1, and the gateway information is 202.16.1.254. So the IP. Okay, after this, we actually have finished all the PC's IP address configuration. And next, we will configure the core switch, right? So for the core switch is the SW1. And first we have to create the VLAN. Okay, we have two VLAN. And enable configuration terminal and into the configuration mode. And create the VLAN 10. Okay, after this, add the interface. So here we can say the gigabit 1 belongs to the VLAN 10. So add interface gigabit 1. Okay, after this, we will create the VLAN 20. And then add the interface gigabit 2 to the VLAN 20. So here is the gigabit 2. Okay, and then we will set the SVI interface IP address, right? So interface VLAN 10, and the IP address is 192, 168, and 10.254. The segment is 24. Actually, you can use this way. It's the same. Yeah, it's the same, right? And for this, we will choose the interface VLAN 20. Okay, interface VLAN 20. The IP address is 192.168.20.254. Okay, and the segment is 24. So after this, we will configure the interface to connect with R2 device, right? And then we go to the interface gigabit 0. And if we configure the IP address 12.0.01, okay, and we will find this command doesn't support this command, right? So we will see its IP address, and we can see our command can't tap the IP address, right? So now we have to tap the no switch port so that we can configure the IP address on gigabit 0. Okay, IP address 12.0.0.1 and 24. Okay, so I think you know the function with this command. Okay, after this, we will go to the R2 device. So now we can modify the host name so that we can recognize this device easily. It's W1. Okay. And we can store the configuration so that maybe some errors on the device. or you power off and power on your device, but the configuration won't lose. Okay, so it's a good habit for you. So after we configure the SW1 and we go to the R2 device. And first we can modify the host name R1. Okay, oh, it's R2. So after this, and we configure the IP address, it's actually the gigabit 01, this IP address. And this IP address is connected with SW1. So this IP address belongs to the OSPF area 0. Okay. So interface gigabit 1 and the IP address is 12.0.0.2 and the segment is 24. Okay. After this, we will configure the gigabit 0. So we can see this interface belongs to the internet. So interface gigabit 0 and the IP address is 100.1.1.2 and net mask is 24. Okay. After this, we will configure the IP address of R1. Okay. Okay, we can start the configuration and show IP interface brief to see the IP address configuration is correct or not correct. Okay, so next, go to the R1 device. And first, modify the host name. Okay, and then configure the IP address of R1. And here we have two interfaces on R1, right? First, interface gigabit 0, and this interface is to connect it with R2 device. And for another interface, gigabit 1 actually is the gateway information as the server, right? Okay, now we adding to the interface gigabit 1 and configure the IP address. Okay, after this, we will configure the gigabit 0. And IP address information is 100.1.1.2. The net mask is 24. Okay. So after this, we will check the results of our IP address configuration. Okay, and then start the configuration. So maybe now you finished all the basic configuration. Here we suggest you can do the pin test to test the directly connection is okay. So here we can go to the R2 device and the pin 100.1.1.2. Okay. So the connection is successful. And another device is pin 12.1 or .0.0.1. And we can see the pin test successful. Okay. So now we will to create the OSPF configuration. So for the topology, we can see we just enable the OSPF process on SW1 and the R2 device. Okay, so go to the SW1 device and enable the OSPF 1. Of course, now you can type the root ID information. Okay, like to set the root ID. As the physical interface, actually, you can create a low-back IP address for the root ID. Okay, but now we can skip this step. And network the segment So if you forget which IP address you have to network, you can use the show IP interface brief to see all the IP address information on your device, and then you will know which segment you want to network. Okay, so network 192 and .168.10.0. And the word mask is 0.0.0.255 and arrow 0. So we just have to network this segment to the backbone. Okay. Network 192 and 168.20.0. And then the area is area 0. Okay. And next is 12.00 area 0. Okay. So after this, actually, we have finished the OSPF configuration on SW1. Then we go to the R2 device. Router OSPF 1. And here you can set the route ID information for R2. Okay. And now we skip this step and to configure the network strictly. Network 12.00. Okay, after this, actually, we finished all the configuration. Let's start this configuration. Actually, now the SW1 and R2 will build the neighbor relationship, right? Okay, so show IP OSPF neighbor, and we can see the state is 4. Okay, so now the OSPF configuration we have finished. So here we have to mention we don't network the gigabit 0 to the OSPF, okay, because the gigabit 0 belongs to the internet. Okay, after this, we have to set the NAT configuration to let the traffic belongs to the OSPF go through, and then can access the server results, right? So now we will do the NAT configuration. So for this topology, we can see the R2 device is the only device to connect with the OSPF area and the internet. So the R2 device will become the NAT device, right? So we will do the NAT configuration on R2 device. Okay, so now first we have to capture the PC1's traffic, because for the 6 requirements, the PC1 can access the server, but the PC2 can't. So now, first we have to create the ACL. Okay, so first is the IP access list stand 1. And for this ACL, we permit the 192.168.10.0 just for this domain to pass through our internet. Okay, permit. Okay, now we just capture the traffic belongs to the PC1, but now we don't permit the 192.168.20. Okay, so this is the PC2's domain. And after this, we will configure the NAT configuration. So first is the interface gigabit 1. So the gigabit 1 is belongs to the NAT inside, and the gigabit 0 is belongs to the NAT outside. Okay. So the interface gigabit 1 IP NAT inside. gigabit 0, IPNAT outside. Okay, after this, actually, we have to create the NAT port. So here is command is the IPNAT port. And the port name is Ruijie, okay? And the port range IP address is 100.1.1.1 to the 100.1.1.1. It means we just have one IP address for our PC to access the internet, okay? So if you want to more IP address, you can extend the range of our IP address pool. IPNAT pool, and the name is Ruijie, okay? 100.1, 100.1, and prefix is 24, okay? And after this, we will set the IPNAT in set source list 1. It means the source IP address belongs to the list 1. The list 1 is 192.168.10, okay, belongs to this domain, and where to match the NAT pool get this IP address, and then to access the internet results, okay. IPNAT inside. So the source information is the list 1. And the pool is the Ruijie. And for the Ruijie pool, we just have one IP address to use, right? And use the overload. Okay, after this, actually we have finished the NAT configuration. And the next, we will do the distribute the default route, right? And actually, we will do the distribute on R2 device. Okay. So we start the configuration and go to the configuration mode. And here, the default information originate method actually is the first method for us to configure the default information distributes. So this way, assuming there is already a local default route, it means we have to configure the default route on R2 device so that we can do the default information originate. So either manually configured or learned from other routing protocols. So here first we have to create the default routing. Okay, for this default route, we can see the IP route is 0.0, and the interface is output interface is a gigabit 0. Actually, this interface, right? And the gateway is 100.1.1.2. Okay, is for this IP address is the next hop. And after this, we will do the distribute default route, and we will go to the OSPF, okay, route OSPF 1, and default information originate. Okay, so this is first method. And now we can see the route information on R2, of course, show IP route. We can see the default routing entry here. Okay, this is static, right? This is static routing entry. So now we will check the routing entry on SW1 to IP route. We also can see the default routing, right? This is the default routing, and the mark is OE2. Okay, this means the OSPF external and type 2 routing entry. Okay, so here is the SW1 learn a type 5 default root with the root type of OE2. Okay. So after this, we can see the same routine. Okay. So if the default root manually configured on R2 is deleted, so SW1 will not be able to learn the default root, which means that distributing the default root into the OSPF process fails. So if we delete this routine entry, so SW1 won't have this routine entry. Okay, so before this step, we have to do the ping test so that we can see the PC1 can ping the server, but the PC2 can't ping the server. So before do this command, we have to do the test. Okay, so we go to the PC1 and ping 200.16.1.1. Remember, it's 1. Okay, it's 1. And to see the ping test results. Yes, and we can see here, right, is successfully. And now we go to the PC2 and ping 200.2.16.1.1. And we can see the result is timeout, right? And the PC2 actually can't visit the server, but for PC1 can visit the server resources. So because we configure the ACL, let the PC1 go, but delay the PC2's traffic, right? Okay, this is the correct results for this lab. Okay, and for next step, we have to delete the default root on R2. And now we go to the R2 device. Okay, and then no IP root. Okay, after this, we can check the routing table. And here there isn't the default routing table. And we can check the results on SW1. So also we can't see the OE2 default routing table, right? Okay. After this, actually, we can use another way. The way is the default information originate always. Okay, what does this mean? It means redistribute a default root to the OSPF process regardless of whether there is already a local default root. So for R2, actually, we delete the default router, okay, and now we can't see the default routing entry on R2 and SW1, right? But if we configure the default information originate always, this command, and we can see the routing entry on SW1. So now we configure this step. So the root OSPF 1, okay, and to do the default information originate always, default information originate always. Okay, after this, we can check the results on SW1. And we can see we have a default routing entry here, right? Okay, so this is the results. So here, R2 does not have a manually configured default route and does not learn one from other routing protocols. Okay, here is the same. It's the same with our routing entry. Okay. So now, please note in this scenario, SW1 can send the data packet to R2. Actually, we have the default routing, right? And the SW1 sends the packet to R1. After this, the R2 does not have a route to the public network because the R2 don't have the default routing, right? Default routing. So actually now the PC1 and PC2 can't access the internet. So packets will be dropped and cannot be forwarded. Okay, so now we can do the ping test here. It's the same, but we can see the results is destination network unreachable. Okay, so for the PC2, actually it's the same. We also can see the results. Okay, so it's very important to establish the reachable route to the public network on R2. So we can configure the routing default route on R2. Actually, we can create the new protocol, okay, like enable the other protocol and set this IP address to this protocol, okay, and do the network, and so that the public network learn the IP address information between each other. Okay, so for example, we can add the default route. Okay, so now the last step is a verification, test the connectivity. So actually we have test all the connectivity between the PC1 and the server and PC2 and the server. Actually we do the ping test before we delete the routing entry, and after we do the ping test successfully, we do the no comment, right? And after this, we actually to do the ping test before the PC1 and server and the PC2 and server. Okay, so here is the verification results. We just analyze it. So test the connectivity between PC1 or PC2 and the server by conducting tests on both PC1 and PC2. So note that due to the NAT restrictions, so only PC1 can communicate with the server, where PC2 cannot because of the ACL, right? Okay, so here is the results for the successfully. Okay, so the PC1 can ping and the PC2 is a timeout. Okay, it's the same with our lab. So next we will overview the key points. So first, the key points is the distributing default routes using internet ingress device. So in this lab, our internet ingress device is R2 device. For the R2 device, it belongs to the OSPF process, of course, belongs to the internet work. So distributes a default route into the OSPF process and allow SW1 to learn it, run the default information originate always command. Note that the default route will not be present in local routing table of R2. We just can this routing entries on SW1, right? So this means that after the line packet reach R2, they cannot be forwarded outwards without menu configuration of a default route. So the default route on R2 is necessary to enable line users to access the internet. Okay. So configuration recommendation is in line internet scenarios, the ingress router should have a manually configured default route. So we do the IP route and 0 and at the next hop, right? And distribute the default route for the OSPF process use the default information originate command so that we can find other device don't have the default routing entry. Okay, so we can use the default information originate at the IP route this command and to create the default route. Okay, so next is the two key points. The distributing default routes using the OSPF spatial area. So first is step area automatically distribute a default root of OIA tab. And the two is the ABR roots in an SSA area requires the default information arranger in it or default information arranger always. These two commands to distribute the default root as it does not do so automatically. So the default root is present as tab type 7 RSA information. So for the tab 7 RSA information, we have said it's special for the SSA area, right? Other area don't have this tab. Okay. So the tab 7 RSA information will represent the ON1 and ON2 routing entries in an SSA area and does not need to be present in local routing entry. So the next is the ASVR router in the SSA area distributes the default route in a menu consistent with the ABR router. However, the key differences is that the ASVR router requires a pre-exciting default route in the local routing table. Okay, so the last key part is the ABR router in the totally SSA area will automatically distribute a default route for OIA. So here, the key points for the two parts actually is that the default information arranger, this command for step area for an SSA area, this special area is not the stand area. Okay, and we have to notice these key points. So that's all for this class. Thank you for watching.